In this tutorial, we're going to look at a really common algorithm known as the bubble sort algorithm. Now, this is the simplest but the slowest of all sorting algorithms. I've got here in line 1 an integer array that I've declared and populated. This is a quite useful way of adding items to the array if A, the number of items is relatively small, say no more than 10, and also that you know what the values are in advance. The compiler will automatically figure out what the size or length of the array is. In this case, I've got 10 items, so that's going to be a size of 10. Now, this algorithm uses what we call a flag variable that I've declared and populated at line 2. This is actually going to control the outer loop. The bubble sort algorithm actually uses two loops, a condition-controlled outer loop and a nested inner for loop. Now, the number of items we need to sort is progressively going to get smaller, and the way I'm going to do that is with this num2sort variable. And then if I do need to make a swap, in line 4 here we've declared this temp variable. It needs to match the data type of the items stored in the array. That's why it's an integer here. So lines 7 to 12, all I'm doing is outputting all of these items, 34, 78, 3, etc., in unsorted order on a single line with a space between each number. Now I've got two versions of this bubble sort here. Just go down here to the first version. This is using a precondition while loop. So the while loop basically runs for each bubble or number that we're placing into a sorted position. So the first time through this outer loop, we're going to place the highest value in the array into the highest index value. So if I look at the numbers in my array that was declared up here in line 1, the biggest number is 768. So the first run through of this while loop, 768 will actually be moved so it's in the highest index of the array, which is currently occupied by 456. And all of these values after 768 will actually be moved down one index slot. So when comparing 768 with 45, we need to do a swap. Then we would be comparing 768 with 23, swap, 768 with 76, swap, and so on until 768 is compared with 456, swap. So that's the purpose of the outer loop, to place the highest unsorted value into the next highest index of the array that's available. And this outer loop here is controlled by our flag variable. So long as the flag is false, it suggests that we've got at least 2 items in the array that are completely unsorted. So the first thing we do is we change the flag inside this while loop to true, because then we need a set of iterations that are doing the bulk of the sorting. These are going to compare each adjacent element, so index 0 with index 1, for example, and it's going to compare those values in those indices. If a swap needs to be made, then it's these lines here that are doing the swap. We take the value in the lower index, numbers I, and put it into our temp variable, because then in line 44 here we're going to immediately overwrite the value in the lower index with the value in the next index. Then, because we stored the value in the lower index in the temp variable, we've got that to assign to the higher index. But once we've done our swap, we're going to set our flag variable back to false. Notice this matches what is controlling our outer loop. This suggests if we've made at least one swap, there could be more swaps within the set of for loop iterations. Between the two for loops, we're going to take one off the number of unsorted items, so that with each iteration of the while loop, and therefore each set of iterations of the nested for loop, our list of unsorted values in this array is going to progressively get shorter. The idea with this is that if we get to the last iteration of the while loop and we set is sorted to true, and this for loop attempts to run, and it does, but what's inside the if statement never runs. Lines 43 to 45 don't have to do a swap because the array is sorted, and therefore line 46 is never going to change the flag. So is sorted is going to remain true when it was set at line 37, even when we get down to line 50. Then 51 is going back up to line 35, but is sorted now is already true at this line, and so the loop ends. To see this in action, I just run this program. I've got two outputs of the array. First one is the array in the unsorted order, 34, 78, 3, etc. And then we can see after the bubble sort algorithm, this is with the while loop option, I'm outputting the array's contents in sorted order. The lowest value 3 is at index 0, the highest value 768 is at index 9. In the next tutorial, I'll walk you through how we can do the same thing but with a post condition while loop.